Choose between Roving Hammer or Roving Accel. In Roving Hammer, the hammer moves to each location and the Accel stays in one location. In Roving Accel, the hammer stays in one location and the Accel, or accelerometers, plural, move to each measurement location. In this example, we'll be capturing modal data on a 15-inch head expander. For brevity, only 9 points will be captured in the z-axis direction. Points are labeled directly on the DUT, as you can see in the picture on the right. In Configure Trigger, configure sensors on the I/O unit. Then set a trigger channel and threshold. Make a few practice captures to tune this value. Set a max frequency of interest and adjust the analysis duration so that the DOT's ring down occurs within the capture duration. Ideally, you want to capture just enough data so that the ring down is captured and no more. That way you can capture faster. Now start capturing data at the indicated reference and response locations. The test sequencer will guide you through the process of capturing each desired DOF. Now that all DOFs have been captured, review the data. Use the resonance cursor to evaluate system resonances. Select one or more DOFs from the DOFs list to analyze a subset of captured data. It is possible to reprocess data by using different analysis settings. Here I will increase the frequency resolution by 4 times to improve the data point resolution at sharp resonances. If you determine that data for a DOF is inaccurate or has flaws, simply delete these captures and recapture at this location. Double hit detection flags data which is not a single pure impulse. The next capture will automatically overwrite previous double hit capture. Now that all captures look good, export the data to UFF for further processing in a 3D modal analysis tool like Emiscope. Use Quick Report to document all capture data as PNG images and CSV datasets. The previous example demonstrated Roving Hammer. This example will demonstrate Roving Accel using 2 roving accelerometers. We'll also be capturing in 3 axes directions. By selecting a corner as the hammer location, we can strike in X, Y, and Z. Configure the inputs as we did before. In this case, I'm going to be configuring more sensors. Use Discover Sensors to automatically locate sensors on the box, and then start labeling them and assigning the appropriate sensitivities. If you have a TED sensor, all this gets assigned automatically. Here I'm going through and making sure that the axis directions of the sensors are set up. This will aid in automatic sequencing and labeling later on. Just as we did before, we're going to go through and tune our threshold and set our maximum frequency of interest. The system automatically picks the appropriate sampling rate to capture the bandwidth that's required. I'm going to set the analysis duration to ½ a second in order to speed up capture times. Now follow the instructions that the sequencer provides. It's asking us to start striking in the X direction. Since I made a mistake there and actually captured in the Z direction, I'm going to reject that previous capture and begin capturing in the correct direction. Double hits are flagged as usual and automatically replaced. Simply move the hammer to the direction and location it's asking and capture all of the locations that the sequencer prescribes. Move sensors to the locations indicated by the pop-up. Here we're going to be moving to location 3 and 4. Once set in place, just begin capturing again to proceed. In roving Excel mode, as many sensors as there are inputs on the box can be recorded at once. This can significantly speed up test time. When we reach the 9th location, we need to disable the extra accelerometer because there is not a 10th location to capture at. Now that all captures are complete, you can export to UFF and do a quick report, just as I illustrated before. You can review results now, looking at individual captures. You can also overlay multiple locations to see how they compare. And you can look at individual captures. You can also easily look at just certain axis directions by filtering the DOF list by typing in the filter area. Here we're looking at just the y-axis. Now to look at the z-axis, just change it to z and then select all the DOFs in the z direction.